Good afternoon, everyone, and welcome to the Construct Innovate webinar series on sustainability planning and construction. My name is Jamie Goggins, and I'm a co-director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology and Innovation. This webinar series is kindly sponsored by ARUP and is supported by the Association of Consulting Engineers of Ireland, Engineers Ireland, Royal Institute of Architects of Ireland, and the Society for Chartered Surveyors of Ireland. This is a 7-part webinar series. In there, this week we're going to focus on passive house and have some great studies around passive house. So for anyone that doesn't know what a passive house is, it's a building that achieves very low energy consumption for heating and cooling through high levels of insulation, really good air tightness, highly efficient windows, heat recovery ventilation system typically, and being carefully designed to utilize solar gains. The standard then, as for us that occupy the buildings, what does that mean? What means that we get to live and work and enjoy comfortable, healthy indoor environments. So we get high quality indoor air, we get reduced carbon footprint, and we have lower energy demands in the buildings compared to conventional homes. So as I said, this webinar is part of a 7-part webinar series in there. And over the next couple of weeks, we'll concentrate around the buildings. And so this week is case studies around passive house. Next week, it'll be around the building envelopes and how we really take care of those to make sure that we achieve low energy health in buildings. Then we move on to achieving high quality indoor environmental condition in buildings. And then week 5 is around retrofitting homes, businesses and infrastructure. Week 6 is around circular economy and construction and how we maximize resource efficiency and minimize waste. And week 7 is around advancing sustainable infrastructure. So this week, really fortunate to have really high quality speakers, really with a lot of experience in delivering passive house buildings. So Barry McCarron, who's the Managing Director of Core Retrofit, he's going to give us some case studies around retrofitting buildings to the passive house standard. And then Patrycja Kochaniuk, who's a sustainability lead from Tallon Walker Architects. She's going to walk through with us and show us examples of use of 3D modeling and designPH to design low energy buildings. And then Fallon, who's an associate director from Architype, is going to give us a presentation on development of passive house schools in the UK. So that's our 3 presentations. So we'll have 3 short presentations and then followed by the Q&A at the end of the 3 presentations. So if you have any questions for any of our presenters, please do post them in the Q&A function at the bottom of the screen. And as I said, we'll deal with all the questions at the end of the 3 presentations. So without further ado, I'm going to hand over to our first speaker, Barry McCarron, who's Managing Director of Core Retrofit. So over to you, Barry.
Thank you, Jamie. I'm delighted to be here with everyone. Just let me get my screen shared. Okay, that should be me. Yeah, so thanks for the introduction, Jamie. Yeah, Barry McCarron, currently now Managing Director with Core Retrofit. So what we're going to do is just give a very short presentation profiling one of our Innovate projects, which is a retrofit to the passive house standard, and give an overview of some that we have in our pipeline as well. So again, a lot of people might know Core. Core is quite well known for its insulation products, been in the market for 30 years, but the other side of the business is Core Retrofit. And again, we're the first ever one-stop shop established under the SCI and have been on the go now since 2016, 2017 or thereabouts. So again, we're operational in a number of the schemes that the SCI run, and overall you're talking around 500 to 600 retrofits with Core Retrofit every year across those schemes. So Ireland's landscape, big targets in play for 2030. We're really looking at 500,000 homes to be retrofitted to a B2, and now with the European Performance Directive coming in next year, that this B2 is really going to go to an A3, and that brings into play the stretch metric of passive house for us here in Core Retrofit, and the offering from me joining the company to deliver passive house Innovate, which I said already is the retrofit standard for passive house. Yeah, so Innovate and the one-stop shop, it works really well, and in some cases you're able even to combine that with the vacant derelict grant that's available in Ireland. So for some people in the right situation at the right time, that's almost 103,000 euros in support that could be an offer. So again, just tight for time, trying to keep to the short sort of version here of things. Really, the passive house for Innovate is no different than passive house for new build. As Jamie sort of outlined, 5 key principles. They are all basically floors, walls, and roof. Is being the first one, is where you have a really good U values, really good levels of high quality insulation, and that's your first principle that drives down your heating demand. Alongside that, it's critical that we get the thermal bridging right, so that's side by side. Then we're looking at the windows, triple glazed, and then air tightness being the fourth one, goes hand in hand with the fifth principle, which is mechanical heat recovery ventilation. And all 5 of those are well proven methodology for getting high performance, genuine high performance. And then when you couple them with renewable energy, you really get excellent low carbon heating solutions in play as well. So from coming in, we've had a pipeline from we started to offer Retrofit, and the first project we have, which I'm going to profile today, is just this standard semi-D, going right back to 1940s really, in terms of a semi-D in Dublin and Glasnevin. And that's the one we're going to profile. So that's the first project in terms of the case study. We also have this one in development in Howth, also in Dublin. I made a joke yesterday. I'm not sure what the lambda value or the insulation level is on that ivy, but it's very much going to be an interesting project all the same, with a brick finish there underneath it. So we're looking forward to the challenges that one would present. And then we've this gorgeous grand design, you could say, up in Donegal, and that's really going to be an exciting project for us in core retrofit as well. And again, all 3 of these to the passive house Retrofit standard. So the big challenge that I usually identify in terms of these are the 2 of the principles that are the hardest for people to adopt to are thermal bridging, which is really very well depicted in this little graphic, which just shows all the red areas being the areas of thermal bridging. Not everybody is au fait with this. So that's one, and it really hammers home the importance of good design. And the other area that goes hand in hand with this is also ventilation. And again, we'll take a deep dive in this at the moment. Now, so the Glasnevin project, this, as I said, is a 1940s project. It's up sitting at an FBER, so that's 405 kilowatt hours. And we're proposing now to get this to an A1 and meet the passive house standard in combination. So it's going from a whopping 405 to 20 kilowatt hours. The treated floor area is roughly 201 meters squared. The form factor of the building is not too bad as well. You can see there. Again, for those that aren't familiar with that terminology, a bungalow would be quite bad. It'd be up at 3 or 4, and I know some of the other presenters are going to touch on that. So the heat and demand via the initial PHBP and designPH is 21.1. So that comes under the passive house level of 25 kilowatt hours, and the heat and load just on the by comes in at 13 watts. So it's really good high performance. The U values on the project are all under the 0.15. Caught for time here, so can't go into every single wall type, but there is a variety of different arrangements in this project. But that's a good illustration of how passive house isn't that rigid. It does allow a certain degree of flexibility. Building on the earlier slide where there's thermal bridging, I always like to quantify that and then give a reference. So the thermal bridging in this house, which you can see illustrated there in the stick frame, again, that's pulling out exactly what's there in terms of thermal bridging. That's 405 meters, all things added up, for this building in Glasnevin, and it's just a semi-D. And again, a useful but sort of comical, reference point is that that's higher than the Empire State Building. So really, to hammer home that point on thermal bridging, it's a significant meterage when it's all added up. The overheating, when it was initially modelled, because of Retrofit and because of retrofit projects, you're usually caught, and you can't really, use PHBP as a design tool because the buildings in situ. but the initial analysis came in at an overheating of 9%, but without introducing any mechanical ventilations, and with careful design there and implementation of a passive cooling strategy, we were able to get that down to 1%. So I'd expect a question on that afterwards. In terms of the running cost, this means that down to 21 kilowatt hours, which is outlined there, that's going to extrapolate to about £500 a year, €500 a year, and the domestic hot water for this again coming in at an expected 585. So all in all, when you combine that with an electric cost, which is again based on a standard situation, and the PV being in play, you're talking an overall picture here in the next slide of a total energy cost of £2,500 a year. When you compare that to what the house was running at and being lived in as well, that works out at a saving altogether circa of €6,100 a year. And again, what is taught in a lot of the passive house teaching is to do a full appraisal of that and extrapolate it over a mortgage. And these homeowners have a 30-year mortgage. So you're talking a combined saving over that period of time, amounting to, again, a whopping 183,000 if it was the full thing, but 51,000 on the other hand is the running cost. So that's a good picture of the before and after. Again, just when we're talking about retrofit, it goes hand in hand in this carbon story. If we're going to tackle our targets in terms of climate change and everything else, retrofit and really a lot of my energy and passion comes into Innovate now, because we're getting to retrofit the existing buildings that are already there. So we're capitalizing already and we're winning already on that front. And then by using Retrofit as a stretch metric within this company and on as many retrofits as we can, we're really addressing this operational story. So not only in terms of energy and costs, but also for future metrics, carbon is a really good story as well with all of this. And of course, we're moving from NZEB, thankfully, into ZEB. So again, this goes hand in hand with the trajectory of the building industry in Ireland. So that's me rallying through my 15 minutes and trying not to overrun to take time away from the other presenters, but hopefully you can pick up with me at the end when we're finished the next presentations. And yeah, thank you.
Brilliant. Thanks, Barry. That's great. Great to see the retrofit projects, and I suppose it's a key target for the Irish government in terms of getting 500,000 homes retrofitted in there, and to a high standard in there as well. So, and great that we have this standard from the Passive House Institute of Innovate in there to try and hit to. So our next presentation is all around 3D modeling and design of pH to design low energy homes. And Patrycja is sustainability lead at Tallon Walker Architects. So over to you, Patrycja.
Thanks very much, Jamie. Hello, thanks for having me here. So my presentation is going to be completely different, but at the same time, you're going to still see the same graphics from time to time. I hope it's showing now.
Yes.
So I'm going to be looking at the feasibility study at a very early design stage, where we have the site and we have an idea of the building, and we try to find the best place for it, and maybe have a look at some go a little bit deeper into the kind of elements of the fabric. So what is designPH? It's a plugin for SketchUp, so it lives within SketchUp software. It works as an extension. So we're using a SketchUp for developing the model, and then through designPH's tools we apply the U values and so on, the thermal properties of the building. And it calculates the heating demand. So it's all about the building physics within the design for low energy buildings or passive house buildings. So it's the first part of the design. from designPH, it needs to be exported to PHPP in order so we can apply the services and the heating systems to get the actual energy use. But this is the first step. And for the preliminary design, this is what we should be focusing on. So the process starts with just importing the site to the SketchUp. We can do it through geolocation, so we can import the Google map with the terrain and with the objects. For some areas, I think Dublin is pretty much developed. It can be just simply put in. Then we look at the building. So for the model, we only model external skin of the external envelope. So it's a single skin. And then we apply its properties through just right click of the mouse, and we pick the U value from the list. So it's very simple. So for the walls and floors, we apply the U values, thermal bridges. For the windows, it uses the components in SketchUp. So we can just apply the thicknesses of the frames and then the U values and G values of the glazing. So it's quite detailed in what the SketchUp can do. There's quite a lot of information in there, and it's quite reliant. And apart from what we put in, the information that we put in designPH, for this, when we look at what I'm going to be looking at later, we also need to consider overheating, and for that we need to do the export to the PHPP and apply the ventilation settings so that we can see what's the problem with the overheating. So we locate the building within the site. So in this case, it's a 4-story office building with the floor area of 4,800 square meters. The shape was already thought over, and we just put the most efficient form factor possible. So this is how it looks like after pressing the button for running the analysis, and we can see the same red buildings that Barry was showing. So this is how it looks like after it's analyzed, and the same graph on the left that's showing the balance of the energy, so the losses and the gains. And in the case of the building office with a lot of glazing, you can see the majority of losses are through the windows. And also, I should have said, I've used double glazing for this building, so the aim would be to achieve the low energy building level. It's not a passive house level, but we can see how big of an impact the windows are. And also the other thing worth mentioning is the internal heat gains part, which is also very, very high in commercial buildings. And that's a part of why overheating is an issue. So looking at the design options that we had here, we have 2 locations. So the first one is orientated on the north-south axis. And we're using full glazing here. So we can see straight away the 24% overheating is way too big. For this study, we were trying to achieve the under 10% overheating targets. That is kind of like the first step during the design, and then it can be optimized further with the design of natural ventilation or mechanical ventilation if need be. But for the building kind of envelope first pass, the aim is to get under 10%. So what we can do is we can reduce the G value of the glazing, which means the heating demand raises because we don't have as many solar heat gains. We can see them in the yellow area. So this is 25 and it's reduced to 18 here. But at the same time, the overheating is lowered, but it's not quite there. So we had another pass, and here it's hitting the target with the larger overshadowing devices outside. So this is the first option. The second one is we're looking at the other direction. So we have now long elevations facing south and north. And what it does is straight away, the heating demand is slightly lower than our first option with the other orientation. And with the reduced G value and a little bit of shading, we are achieving what we wanted to achieve for the overheating. And so then we looked at another option which reduces the glazing. So going back to this orientation, the glazing is reduced by 50%, and straight away the overheating is lower, even for this baseline kind of level, and then lower again with lower G value, and similar for this one. So out of all the four options, the east-west axis with low amount of windows is the best option. And it's not surprising, but I think it's valuable to see it and see what impact it does at the very early stage of design, and we can know for sure that this is what it's going to be. So these are the four options, and if we look at the line from left to right, you can see 8% improvement between for the fully glazed facades between the orientations, and similar for the facade that's 50% less glazing. But for the other going up and down, the comparison between the amount of glazing is making much bigger difference. And finally, the comparison between the first option and the last option is 36%. So just by using exactly the same materials, the same basically building, just orientation on the sides, the amount of glazing is making a lot of difference. So that's from me. This is what we do at a very early design stage. Thanks, Jamie.
Brilliant. Thanks, Patricia. That's great to see. You looked at that, that investment early on in terms of decision making, having some quick models that you can put together and look at the impact of orientation, proportionate glazing, and the shading in terms of the overall heating demand and overheating on the buildings. And many people forget that overheating is now coming as big of concern as it is in terms of reducing the amount of heating that we need to put in the building in this. So trying to get that balance.
It has always been a problem, but it was dealt with mechanical ventilation, which we just need to pay more attention to this.
Yeah, exactly. So we're trying. What we're trying to do is have low energy buildings, so try and reduce the amount of mechanical ventilation that's required. Therefore, have less energy demand on our buildings as well, and that's where good design comes in. Good concept design comes in there to be able to achieve that. Okay, so we're on to our third presenter. So if anyone's any questions for our first two presenters, then please do pose them in the Q&A function at the bottom of the screen, and we'll deal with all those after the three presenters are finished. So over to our third presenter, who's Anne-Marie Fallon, Associate Director from Architype, and she's going to talk about development of passive house schools in the UK. So over to you, Anne-Marie.
Thanks, Jamie. Can someone just give me control to share my screen? There we go. Perfect. Thank you. Great. Okay, just let me load it up here. Okay. Right. Welcome, everybody. So we're going to go from that very early stage, great work in designPH, to the kind of completed outcomes of Passive House, and just a little bit of a flavour of what's going on in the UK at the moment. Sorry. So I'm Anne-Marie Fallon. I'm an Associate Director with Architype, and I'm also one of the new co-directors of the Passive House Trust in the UK, phasing into that job over the next couple of months. But I'm here to talk to you about Architype's development of schools generally over the last couple of years across the UK, and in particular Scotland, one more detailed case study to go through. Last year, Architype celebrated their 40th anniversary. They have their practice with 3 studios established across the UK. And you can see that actually from the early 1990s, we've been gradually improving our energy use intensity outcomes for our projects. This is going back looking at the actual operational use of these buildings currently. And, you know, we're on a downwards trajectory. And I think I'll really encourage people to look at their own practice and approach in the same way. I'm just going to show a few slides of completed projects and some more recent projects. So we mainly focus on passive house projects as a methodology in the practice because of the quality assurance that comes with it. So partially for the climate emergency, but also because there's a quality assurance that we know clients, especially post-Grenville, are really looking to amplify in their procurement processes. So Harris Academy, Hackbridge Primary, kind of a net zero in operation, Passive House School in London, Maybury completed last year, Passive House School in Edinburgh, Curry Community High School, another large kind of 12,000 metres squared high school sports specialist facility in Edinburgh with a Passive House pool, just going through certification at the moment. And then finally, one of the most complex sites we've ever worked on, right beside London Bridge, in St Catherine's Dock there in London. A very polluted highway to the north, very congested, difficult site to develop a passive house project on. But the client actually chose passive house in this case because of the air quality benefits, given the noise and the really poor air quality in this particular part of London. So we've done a lot of post-occupancy on our own projects. There's a list there of our primary schools that we've kind of learned the early lessons from as we were just hearing about the kind of overglazing, you know, the localized overheating that tends to happen in projects, learning those lessons and bringing them forward over the last decade or so. And being able to evidence that, you know, some of the standards out there at the moment, the net zero carbon building standard, for example, that various industry members have set in the UK, that the Enterprise Centre, the University of East Anglia, that project has been performing at that level that they've targeted in 2050 for 35 years ahead of the 2050 target. So ever since it was completed in 2015, it's achieving that energy use intensity that's been set. And just with my Passive House Trust hat on, just a bit of an overview at the end of 2024, where Passive House certification was in the UK in relation to units, number of metres squared of area, etc. And there's a kind of an ever increasing amount of buildings being delivered at scale. So back to schools and kind of the specialism I'm talking to you about today. We know there's a lot of environmental design challenges in schools, and I understand there's actually no passive house schools in Ireland. Would love to know more about that if anybody has any information. But we are dealing with a number of parameters, and of course, you know, we can solve all these things technically with mechanical intervention, but that usually increases our energy costs and can compromise our comfort. And this is a school that we did post-occupancy of, not one of ours, but another school that was completed in 2017, lauded as one of the most, you know, energy efficient new low carbon buildings in this particular local authority. And we can see that the indoor air quality for various classrooms in this particular week in February are very, very high, and windows are closed, they're not being opened, and various different issues. By contrast, Passive House is getting us down to very healthy low CO2 limits and providing that really good indoor air quality in our buildings. And we've just done some more research with UCL in London, looking at quantifying how much hazardous normal classrooms are in the business as usual case of education spaces are when compared to bio-based passive house projects. So, you know, using low VOC natural materials internally and coupling that with the indoor air quality parameters of passive house, and just being very mindful around how we look at compound risk. So not just looking at the proxies of different VOCs, but actually going into detail, because we have some compounds that can be present in education spaces that are 100,000 times more hazardous than other spaces or other compounds. So again, we'll be having more coming out on that in due course. So won't stay too long on briefing and early design, because we've just had a good seminar on that. But just a little bit of an overview of the design team, because I always forget to put them in, and this is a team effort. So thank you to the whole design team for getting this over the line. Riverside Primary School is the first Passive House certified primary school in Scotland. And there's several in the rest of the UK and across England and Wales. But this was the first one in Scotland. A 2-stream, 500 pupil school with nursery and special needs provision and around 70 full-time staff. And this project was delivered and designed through COVID. So we had all of that kind of economic situation to work with, and was completed in June 2023. It was a tandem build site. So you can see here the existing school. It was in the 1970s, single story school. There was some rack issues within the structural integrity of the school. So it was nominated for a demolition. And we were able to utilize the optimized gain on the site, but also refocus a sense of place within this local community in Perth, just north of Edinburgh, where we were able to reorientate the site. We had to decant the nursery, but the existing school was allowed to continue on the site as well. It was a consolidation effort between two schools that came together. So a lot of community work, a lot of involvement around pedagogy and other things that I won't be able to touch on today. The GIFA is around 4,300 meters squared. It was delivered for a modest budget at the time of 20 million, given the Ukraine volatility and the other kind of economic events that were happening around that time. And it was the first steel frame passive house project that we delivered, and one of the first steel frame passive house projects actually certified in the UK. How this all came about was that we had enabler from Scottish Government. So the Scottish Futures Trust, the infrastructure arm of Scottish Government, essentially provided funding based on targeted energy metrics. So some of this was around indoor air quality. We had to comply with in-use energy targets to achieve 100% of that funding, and it's outcomes based, so it means it's over 25 years the local authority draws down that funding. So it's not a case of have your cake and eat it up front. You have to prove the building is performing and staying within good condition, and one of those metrics is our energy use intensity metric. So when we got to rebase status stage 4, so just pre-construction stage, our energy metric that we were banking against, that graph that you just saw on the last slide, was around 62 kilowatt hours per meter square per year for the core hours of use of the school. And we're just finished 2 years of post-occupancy on the school now, and we still have a relationship with the client, and we're down at almost half that. So there is a little bit of contingency that was in there and a bit of conservativeness because of some of the small power and other appliances that went in. So there was a great learning experience for us, but there's also a lot of optimization the client did subsequently. The project began as a CLT project, so much more simple flat substrates, easier to achieve air tightness and fabric and thermal continuity, but have evolved into steel frame because of the local supply chain constraints and the need to save about, I think, 850,000 on the overall price to bring it in to where it was required to be. And this actually evolved into national guidance, so a technical position paper. We're hoping to release another update to this next year, very applicable, lots of really good information in there that would support passive house certification in Ireland and just general good quality and workmanship in construction. So really encourage you to download and read that document. Could go into it now. I know we don't have that much time. So again, did that really affect, the VE process, our design intent? We really hoped not, but it did present a lot of other challenges for technical detailing and ensuring that we met the U values and all the other risk factors as best we could. And we don't feel that the overall internal experience for the students has been affected too much by that process. So here's some photos just of the project going up on site. Air tightness membrane was Proctor wrap tight, wrapped on a cement board, so outside the steel frame. And then outside of that, again, there was 180 mil of Knauf rock, Knauf, I can't remember the name of it now. I'll find it for the Q&A. A Knauf product that had a kind of wind tightness facing on the outside of the material to help with the wind washing and to reduce the wind washing where we could. And there was some insulation then within the SFS infill. So even though the form factor was quite favourable at 2.1, we were up in Perth, a slightly different climate file, and we were building a secondary school at the same time, and we were able to get away with U values of 0.2 watts per meter squared Kelvin on that secondary school because of its very favourable form factor. But on the smaller school, a little bit further north, the average U value for the walls was between 0.13 and 0.14, so a little lower than the larger project. A little bit on the MEP. So this project was developed through COVID. So the M&E for the ventilation approach had about 30% extra redundancy built into it because the client was quite nervous about, the next viral pandemic that might happen. This required the project to be updated and beams and ducts and etc. to be upgraded to meet that demand. But as a result, even though the overall ventilation system itself is designed for 12 litres per second per person on average, in that boosted facility to you know, prevent the next kind of viral pandemic, even though I think you'd probably keep your children at home if that happened, or you would half the class sizes so that you'd get more volume of air for those people in the classrooms. The average building ventilation rate is 6 litres per person per second, and we're still getting really exemplar indoor air quality. The hot water was also really optimized. Again, really useful CEPH journal that Baker Hicks developed, where we were able to save about 700 litres of storage of hot water across the scheme by going with instantaneous electric. And there was a lot of reflections with Perth and Kinross Council, the client, around how they experienced the project. So, you know, controls, BMS, and how all those different plants and systems engage with each other. It's really important to have that tied down. PVs were quite an interesting one. You know, if you can't send that PV energy somewhere where it's difficult to manage or get advantage from as the kind of client or owner of the site. And I'll come back to the oversized substation in a second. How did they reduce energy consumption even further in year 2? Well, I found this probably the most compelling of all the findings we have of this project, where they actually reduced the heating time per day because of the fabric of the building is so good in terms of performance that they were able to drop the time clock by 3 hours. So 9 to 2 p.m. the school's open from kind of 7:30 to 5 because there's a nursery running all day as well. And the MVHRs don't actually, the ventilation don't turn on till about 10 a.m. And that's to do with how the school operates. So there's very much an open door policy. All classroom doors are open. Students come in that 10 or 15 minute period in the morning, and they've monitored it. They have sensors all over the building, and they find that the indoor air quality is not affected by delaying the start of the MVHRs in the morning. And of course, the MVHRs then turn off overnight as well. So again, all very energy saving. Flow temperatures were reduced as well. But again, this local authority are really on top of how they control their estate and how they optimize their building performance. So they've just been saving carbon left, right and centre purely through building optimization, even on a passive house project, which is really great to see. Just to mention briefly where our upfront and whole life carbon targets are sitting at the moment. So the Scottish Futures Trust have, since this project has been developed, brought out an embodied carbon target, an upfront carbon target. And we're sitting, even with steel frame, at 544 kilograms of CO2 for that. And then approximately, with our operational energy included, that the whole life decarbonised scenario is around 1,165. So remember, that's reporting the operational energy as well as the actual embodied life cycle energy at the same time. Very briefly on how does a project like this get actually delivered? And we all talk about collaboration, but this is really genuine, actual collaboration. You know, having your passive house champion, you know, on the phone or on FaceTime, talking to you about issues on site, being on site quite regularly, giving the right support to the site team, making sure that we're really involved and we're not stepping away from that process. And that also involved giving toolbox talks all the way through the process. You can see actually COVID having an impact there, kind of a bit of nostalgia in the site cabins. And then in this case, there wasn't a kind of model example hut built on the site. We actually picked a corner of the site alongside the contractor to sign off on samples as we went through. So in terms of making sure quality was benchmarked and acceptable, and new trades were brought in and brought to that side of the site and trained up on what to expect. Passive house evidencing, I see a lot of concern with cost around passive house and quality assurance and how we evidence, and really it doesn't cost that much at all to just take basic records of the products that are coming to site and locating them and ensuring that they are installed properly once everyone is on board with what we're trying to work towards. And this project, the contingency stayed very under budget. So there wasn't like a 20% creep on cost on this project. It was ran very tightly. And the most compelling, another compelling thing for me is that it's the first school in this local authority in 25 years that hasn't had a leaking roof. Such is the quality of what we do tend to deliver in the construction industry at the moment. And that is apparent across several local authorities that I've spoken to. When they actually talk about defects, and they are getting defects a huge amount in their capital projects. A little bit on POE and then I'll wrap up. So the post-occupancy evaluation, or the building performance evaluation as we try to call it now, is also wrapped into the outcomes-based funding for this project. So you can't get your funding unless you deliver 12 to 18 months of building performance evaluation of the scheme once it's completed. So that was a qualitative survey and workshops with the staff and pupils. And some really positive feedback there, bearing in mind the condition of the two schools that the communities came from were really at the end of their life. This school has really brought people together. And when we get into the quantitative side, you know, looking at the energy monitoring across the whole building, looking at how low the hot water and heating demand is, The kitchen, it's a catering kitchen, so it's doing, you know, 600 meals a day, hot meals, and just seeing the server. And again, the BMS, interestingly, you know, does take up quite an amount of that energy. And lighting, we actually had to go in and recommission the lighting in the building because it had been over-commissioned to be too bright. Which I think is what typically happens in the summertime when you're trying to hand over buildings anyway. But that in itself saved 60% of just the energy for the lighting. So really, you know, making sure your lighting's commissioned appropriately is, you know, really important. Coming back to the substation, this is a challenge in Ireland, especially around Dublin and some of the bigger cities where we don't have the grid capacity. You know, we've a load of data centres somewhere, they're taking all the energy, and we're trying to build our housing over here, and there's no energy to build the housing or to run the housing. This substation for this school is only using 30% of its capacity, which was agreed at construction, which is the incoming load from the grid, and that was 400 kVA. At the start of the design process, we had a lot of inexperience, a lot of nervousness within the design team, and the M&E engineers really wanted to stick with a very high kVA incoming substation. And we can see that if we had stuck with that and didn't persuade them to reduce it at construction stage, the client would have been paying even more in standing charges every year. So by recording how little incoming energy load the school was actually using, bearing in mind there's electrical vehicle charging, there's electric hot water, there's heat pumps, there's a lot of electricity used in the building, no gas. The maximum incoming load that was used in year one was 125 kVA, so roughly only a third of the capacity of the substation. So the client's been able to go back now in year two, reduce the incoming load in the substation, and that's a saving of about 7,000 per annum for them on operational costs just on the standby side of things. But of course, as an architect, I would have loved to have VE'd that substation and saved a couple of 100,000 there, maybe rather than VEing to a steel frame. So it's just maybe how we look at these things at the start is really critical. And then just again, what's very typical in passive house projects, very low operational energy, very good thermally comfortable spaces, and really exemplar indoor air quality on the right-hand side there, far exceeding the ventilation regulations for schools in the UK. And we've just touched on overheating earlier. We actually had a heat wave in Scotland, believe it or not, in September 2024. We did earlier on this summer as well. And the average temperature in this school through that period was the coolest, most comfortable school out of all of their schools in the area, which again was a kind of surprise to hear. But, you know, we had that external peak temperature of almost 30 degrees, so not quite London overheating temperatures, but we can see that the temperature internally tracked on a median basis fairly comfortably under the 22, 23 degree area. Some brief insight. We were the architect and the passive house designer. Having an early design team appointment and then contractor came on board quite early as well was really powerful for this project. Really true collaboration, understanding the sequencing, and finally, yes, steel frame is more challenging but not impossible. And the wider benefits of the project are around how it's become a kind of catalyst in the community. We had the Minister for Scotland, John Swinney, open the school kind of formally last year. And the school has had a much wider impact than just passive house certified. We've informed kind of various guidance and industry. It's won some awards, and we're really happy to continue sharing lessons learned on the project as well. And I just wanted to guide you to 2 or 3 other bits of information that might be useful for this webinar series. We've just launched Safe Schools for the Future, free online information to really get momentum behind timber frame construction. Of course, this is in the UK, slightly different regulations, but still very relevant for the Irish context. And again, looking at fire resistance, we were really challenged by delivering timber frame schools in Scotland because of the certification risks and Part B in the UK changing post-Grenville. But we've demonstrated it's now possible. You'll be able to download that on the QR code there. And then finally, please, if you can, maybe join myself and Barry at the Passive House Conference in early October in Belfast and see a lot more really exciting buildings in Ireland that are really delivering to this Passive House standard as well. Thank you very much.